Welcome back, everyone. I'm John Furrier, host of theCUBE here at the New York Stock Exchange CUBE Studios. Of course, we have our Palo Alto studio connecting Silicon Valley and Wall Street, tech and money, creating a wired network as part of the NYSE Wired program and community. This is our Mixture of Experts series, where we bring experts in that are really pioneering and solving real problems with state-of-the-art technology. Nicolas Dupont is here, CEO of Cyborg, officially Nicolas, but I call you Nico because we hung out in Maui together. Great to see you.
Good to see you too, John, as always.
People might not know, but you were on the kite surfing trip with Brian Bauman, myself, Bill Ty for Acti Global. You and I were both learning together, so we bonded on the beach.
We got waterboarded together.
It was fun. I'm intrigued by your company and what you're doing because we had multiple chats. You're going after a really interesting market. Obviously, I wouldn't say there's a magic quadrant yet for it. Maybe there is, but it's really kind of in this emerging space of AI security, encryption, neural networks. It's like in this new era where, you have a lot of challenges and opportunities around, AI native applications, AI native infrastructure, or large scale infrastructure. So there's a lot going on, and you're kind of taking I won't say confidential computing, 'cause that's not the right word, but like that kind of whole generation being redefined in a new way. So talk about Cyborg, the company, when you started it, what does it do? What are you going after?
Yeah. You hit it right on the head, John, that there is no magic quadrant for this. It's a very rapidly emerging space that we're operating in. 6 months ago, we had no competitors. We've got some coming now, which is we're breathing a sigh of relief, 100%. But really fundamentally, if you look over the past, call it 3 years, the center of gravity of AI was all around training. Who had the biggest GPU clusters, who could build the biggest models, frontier capabilities, et cetera. And as a result, the security landscape around AI was focused around training as well. How do you secure model weights? How do you ensure that the model behavior is aligned with the intended goals and purposes? And how do you instill guardrails in the model at training time? But today we're in a bit of an inflection point where customers and investors are asking to see ROI from their massive AI investments. And the way that you see that is through inference. So we're seeing this shift towards inference everywhere, including in security. And fundamentally, in enterprise AI, whatever brand of AI you're running, in order to be able to drive value and get ROI, you need proprietary data. And that creates a huge security risk because you're injecting your proprietary data into this non-deterministic box, centralizing it in one place, and exposing it to all kinds of attack vulnerabilities that are not accounted for with traditional security systems. So we started Cyborg to be able to fundamentally change that through granular cryptography to secure the stack from the ground up.
All right, so first of all, that was great. I just pulled the string and you go. But I have to ask a weird question. Where did Cyborg come from? I love the name, by the way. The name is phenomenal. I think Cyborg, I go to this total sci-fi. I'm surprised that name hasn't been used all over the place. So where'd the name come from? And that's an awesome name.
I'm a geek and a nerd at heart. So, comic books were my best friends as a kid. And yeah, it's a cool name. It's a bit of a misnomer because people think that we're in robotics or something like that. Maybe one day, but for now.
It's definitely a tech name. Cyborg, people think Terminator, think robotics, 100%. Cyborg. Microsoft was called the Borg at one time, like a cyborg. What's the vision? When you started, what was the origination seed? Did you wake up one day and say, hey, or did you kind of roll into this? Were you doing something else? What was the core kernel of why you going after this? You're a young gun. You're like, and you're got all these opportunities. Why this?
Yeah, I'd started the company Cyborg really in 2017 working on data compression, and we pivoted away from that because it's a very difficult market to make any money in. Great optimization problem from a technology perspective, but in terms of
fun, in terms of solving problems and geeking out big time.
Exactly, and that was my main motivation for starting a company. But I was very lucky to have incredible backers that were behind me, a set of angel investors that believed in me when I was an 18-year-old kid in 2017 starting this.
Yeah.
And we took our time to pivot and figure out what was a problem worth solving that was both going to gratify the itch from a technical perspective, but be something that was genuinely transformative for the market. And, in late 2019, I started to have a bit of a frustration with the notion of security at the perimeter, right? It felt like a cop-out generally that was failing time and time again.
Classic perimeter-based security.
Exactly.
Endpoints, or just endpoints is zero trust.
I mean, yes, but there's a number of ways. But when you're defining where it's running, as opposed to defining it from a data-first architectural principle, you're always going to have blind spots that will evolve and bite you in the behind one day.
Yeah.
So I believe that you needed a fundamental restructuring of how we looked at security, away from perimeter and endpoints and defining what the edge is, to granular data security through cryptography, to where each piece of data has an encryption key, is encrypted at all times, including in use, to where you're able to evolve it over time, regardless of where it's running, how it's running. And today, in the age of AI, there is no more perimeter. Your data is everywhere all at once, and also nowhere. And you need a way to be able to assert sovereignty and control over that data, regardless of where it is. And the only way to do that in a reliable manner is through cryptography. With that said, cryptography is great, but it comes with a whole host of constraints. You can't do a lot of operations on data. You can't query it. You can't run inference on encrypted data. So that's where we came in to be able to solve.
So hard problem. So that checks the intellectual curiosity,
definitely
intoxication, some call it, buzz, which is motivating for you, obviously, and many. But how do you make that work? Because cryptography always had an old school overhead notion.
Yeah.
And you mentioned some of the limitations. What are you guys doing? How do you get around that? What's the secret sauce? What's the approach?
Yeah, 100%. You hit it around the head, and that's kind of, it was the challenge, but it was also the opportunity for us because nobody was working on this outside of academia. And so what we started working on was a scheme for encrypted search, specifically because search is the medium through which most applications operate in the first place. And if you're able to search through encrypted data, specifically in AI through encrypted vectors, and be able to reduce down to a scope that you need to operate on, then you can use plain text for that and just reduce the exposure window. So we spent, the ensuing 5 years after this pivot, working on the technology, filing, we got 16 issued US patents to date. We've got several more pending. And we built essentially a vector security layer for AI applications, for enterprise AI. And that is a drop-in proxy that is transparent from an API perspective and largely transparent from a performance perspective, thanks to lots of optimizations we did within our team and with our close technical partnership we have with NVIDIA, which we've got a nice big announcement next month about that.
Well, ironically, we're having our AI Factory series kick off this week. NVIDIA is a big supporter of that, Dell Technologies, and AI Factories, essentially NVIDIA has such large scale, and so the horsepower is there.
Yeah.
So again, this is a dream scenario for you.
Yeah.
Can you tease a little bit about the NVIDIA relationship or no?
Sure. So they've been doing blueprints on their website, build.nvidia.com, that essentially allows enterprises to be able to deploy in kind of a one-click manner an NVIDIA certified software and hardware stack on their cloud of choice that will be able to scale to the performance needs of enterprise AI. And they were focusing on performance for a while because it's NVIDIA, obviously, and security is becoming a key requirement there.
And the NIMs are also engaging, opening up the ecosystem.
Exactly. So that's where we're in that vein. You're very close to it. I'll leave the rest up to the imagination.
I'll connect the dots. Don't worry. I'll get it out of you.
Yeah.
And then my next series of questions. It's like an interrogation here, Nico.
Yeah.
No, but I don't want to reveal because I'll let you save the announcement. But this is a major force because, as I commented at GTC, NVIDIA's, as I love the KP Cache announcement, I was enamored by that layer. But they have a two-sided business model. They got the supply chain nailed down, very transparent with the roadmap. Jensen's always talking about that. But the other side of their marketplace is the ecosystem. They are, for the first time, really intentionally building an ecosystem. Yeah. The NVIDIA of old was like, they didn't really need to talk to anyone else. They did. I mean, when I say, I mean like other industry, they talked to their suppliers and whatnot. But they were in gaming, they were in hardware, they had their OEMs, they had their partners. Yeah. But we're talking about like the software ecosystem, ISVs, value-added resellers, entrepreneurs. Mm-hmm. And now at GTC, this ecosystem is lighting up because they know the next wave is enterprise AI.
Yeah.
They got to run the table on the hyperscalers and neoclouds and then come in to the enterprise. But
Yeah, and
The game's not locked and loaded yet because they got to get the NIMs and these blueprints nailed down.
Yeah, but I've got to say, we are a very small company. We're 10 people, and NVIDIA has been a fantastic partner to us, despite being the 800-pound gorilla in the room. They are extremely nimble, and from a software perspective, they're living 5 years in the future, and they're able to make bets and see the writing on the wall where other companies can't. And so whether it be their developer relations team, their different product teams, the teams we've been working on the blueprint, they've been absolutely fantastic partner and transformative for an organization.
And they're
like
technical
us.
too, so they have the chops.
100%.
All right, so I want to talk about like one of the best use cases in the enterprise, and I love it because we built our own system, RAG, Retrieval-Augmented Generation. It is the best use case because it's gettable and attainable. People are doing it because the systems now with NIMs now with NVIDIA and just other vector databases, vector embeddings and vector databases, you can actually index all your content with math.
Right.
Okay, which is a beautiful thing. That changes the search paradigm.
Mm-hmm.
Okay, great. That's obviously scaling up. Glean's out there. Mongo's got a new one. S3's got vectors on.
For cold storage.
For cold storage. So
Exactly.
it is the standard. Everyone loves it. It's neural network format, basically. That's what I call it. Maybe a little bit of a stretch there, but that is neural network in my mind. So everyone loves it. You told me at a dinner a couple weeks ago that stuff's not encrypted.
No.
That is exposed.
Yeah.
And people think, I want you to explain this. Talk about and it's, by the way, this is a massively growing area.
Mm-hmm.
Glean's blowing their numbers out of the water. And that's all they do, basically. No, that's not all they do, but you know what I'm saying. That's a killer use
company.
case.
Yeah. No.
What about vector embeds? It's going to grow. What do you do differently? What's your cautionary tale? What's the ideal solution?
I love this question. You should ask this question every day, John, because this is super important. This is kind of the most underrated risk in enterprise AI security as a whole. So I'm sure you're familiar with OWASP. They came out with their top 10 LLM risks. And for the first time this year, number 8 on there was vector embedding vulnerabilities. So like you mentioned, vector embeddings are this neural network language. They are essentially the lingua franca of transformer models. And they enable these really intelligent semantic retrieval applications that are, to quote Jensen Huang, the killer app of the enterprise, RAG that is. And it's fantastic. But like I'd mentioned, I alluded to earlier, for enterprise RAG to be able to be valuable for an organization, it needs to operate on your organization's private data, right? So you take this private data that was previously siloed across finance,
Call
HR,
center,
CRM,
sales data, all
engineering.
Yeah.
You centralize it into a vector database or a set of vector databases. You create vector embeddings from them and you store it there. And now you're able to let the agent or the RAG framework intelligently route user queries to be able to find the relevant data and feed it as context intelligently to the LLM to be able to answer the query or to be able to take an action in the case of an agentic workflow. It's fantastic. It's a great paradigm. The big problem there is that it's really twofold. Firstly, you've got a big mischaracterization or a common fallacy that vector embeddings are like one-way hashes, or they are, transformations, or they're encryption of the data. They are not. Vector embedding...
It's just math.
It's just math, exactly. And because it's math, it is invertible. So you can take a vector embedding, you can take text, you can take audio, you can take a picture of somebody's face, create a vector embedding, and you can invert it, with pretty high accuracy, pretty trivially. We did a demo of this at a conference last month. I'm going to the OpenSSL conference in 2 weeks and presenting another one on another vector database. So it's the first risk. These things are as sensitive as the original data they represent.
It's like clean text.
Exactly. It is like plain text. And the second problem is that vector databases are comically under-equipped to be able to deal with the security vulnerability this poses.
Explain that.
Because most vector databases don't roll their own encryption in the first place. They delegate it to the OS layer or whatever. So if you have any access to the vector database, you're toast. Secondly, the ones that do, it's encrypted at rest and in transit, but it's not encrypted in use. And thirdly, if you have an API key exposure, which everybody does, from Microsoft to Google, all the way to all the startups, they commit an API key to their Git repo and boom, it's made public. You're able to extract the vector embeddings from the database like that. And then now you have the vector embeddings, you have the original data. And now as an attacker who's even slightly motivated, who wants to get a cross-section of an enterprise's entire data, I go for the vector database. And that's the huge problem. That's what we're working to solve. So we've built a drop-in proxy that sits between your agent or your AI application, drop in from an API perspective, It integrates with your key management service if you have one, or we can help you roll one out if you don't. And it sits in front of a standard backing store like Postgres, like Redis, like object stores like S3. And it transforms that into an encrypted vector store where all the vector embeddings are encrypted at all times, including in use, until you're ready to feed it as context to the LLM. And so we have two real points that we're trying to make. Number one, you need security for your vector database. Number two, you don't need a vector database. You go on r/rag on Reddit, everybody's saying use PG Vector for Postgres. We're saying the same thing, but instead of using PG Vector, use Cyborg DB, put it in front of Postgres. You get the same performance, you get better security.
So that sounds like that product market fit there. So are you leaning in? Does the lead? Is this your lead product right now?
100%. 100%. I mean, the writing is on the wall in terms of the security and vulnerability. We're going to see breaches, and we're trying to spread the word before we do, because we're in a weird place where we obviously don't want anybody to get breached, but it's going to accelerate our adoption.
As a company that's got 10 people in it, you want to get beachhead.
Exactly.
This is like a layup.
Yeah, exactly.
So not a layup, but for you guys, you're ready to take it down.
And we're grateful to have people like you helping us spread the word.
Well, I'm just curious. That's why. And we have our own vector embedded, as you know, vector database. So maybe I might we'll do a little trade.
Yeah.
Maybe help us. And they're going to suck all our data out.
We'll talk right after this.
And thank God no one's using it, so it's good, except us. All right, so you have a really viable market with RAG right now.
Yeah.
In the enterprise.
Yeah, RAG, agentic RAG, whatever you want to call it. There's a certain, in the adoption curve of Gartner, we're in the trough of disillusionment with RAG right now. Everybody's saying like,
really?
RAG, yeah. If you go anywhere inside of the technical circles, people are saying like, oh, RAG is dead. Context windows are bigger now. You don't need RAG, or now it's graph RAG or whatever. At the end of the day, it's all the same. You are trying to feed the model with data that it did not have at training time. Whether you're feeding it with a vector database or a graph database or with something else, the paradigm is the same. The technical details are changed, but the security risk is always the same.
I don't get why they're shitting on RAG like that, because why would they do that? I mean, is it just because it's been overhyped in their mind, or is it more security? Because I can see the security thing. That's worth calling out, but I don't see RAG slowing down. I think it's going to get bigger.
I agree. That's kind of in that adoption curve. It's more of the level of excitement, because people think that RAG is just, vectorize your data.
They think it's trivial.
Database, it's trivial. But actually try to make a performant RAG application at scale. It's very difficult.
That's the key word.
Great companies that can do that, but also making it secure is next to impossible. And that's what we're here to solve.
Yeah.
We don't want to make a more performant RAG because there are a million engineers working on this, very talented people that have the capability to do it. And there's companies like NVIDIA that are, creating reference architectures for it. We want to make all of them secure.
Well, you got a white space in a massively growing market. It's a nice shim layer between. So explain how this proxy drops in. You mentioned you drop in a proxy. Explain that. Is it a piece of code?
Yeah.
Is it a hardware box? I'm trying to understand. Or is it just calling a managed service? What is that proxy?
Yeah, so great question. So it's a proxy that's initially built in C++. It's C++ in CUDA C++ and some CUDA driver code for GPU acceleration. They can run on CPU or CPU plus GPU for acceleration. And it's essentially a Docker image or a Python module that you install, you launch it, you can put it in Kubernetes, and you point your application that is, let's say you have a RAG application that's using a vector database, Quadrant, Chroma, Pinecone, etc. Instead of pointing it to those with your orchestration layer directly, you point it to Cyborg DB. The API is largely the same, with the exception that now you also inject an encryption key because it's explicit cryptography on this, and then store your data, upsert it into it, and then query it the same way. And it's entirely transparent to you from a code level. All of the cryptography is behind the scenes. And when it's time to be able to do a query and to be able to feed context to the LM, we can just decrypt the top K. You might have a billion items in your collection. You want the top 10. We find the top 10 without decryption and then decrypt the last 10 to be able to feed them to the LM.
And so from a developer standpoint, there's no disruption?
No, exactly. And then from an infrastructure, you are dropping in an additional Docker image. There is that additional container, but we are not a vector database in the sense that we don't store it directly. We plug into whatever backend you want, Postgres, Redis.
And Docker image is trivial.
Exactly.
It's not a major disruption.
Exactly.
It is something to be configured, though.
Yeah, and so it means that you don't have additional infrastructure to maintain. The proxy is entirely stateless, because it's running on Docker and it's not storing anything directly. You can have one, you can have 100 of them running for load balancing and availability. But we delegate all of the, resiliency and strong consistency, data backup and recovery to your database of choice. So you're a Postgres shop, great, you can be happy. You're an RDS shop, likewise.
All right, so you got a great eye on the prize on Beachhead with this great use case. What's the strategy? Are you guys, you have enough cash? Are you raising money? You hiring? If so, what kind of talent you looking for? Put a plug in for what you're working on. Give us some updates.
Customers is first and foremost. And so we are, we're selling to both AI developers as well as security teams, oftentimes both. And we're very lucky to be working with a number of AI native startups that have been fantastic partners. And we're doing a push to, mid-market enterprise because the security risks there and the targets are much bigger. And therefore the opportunity is larger.
All right, so if you're talking about business deals, let's take NetApp, for instance, or
Sure.
VMware Broadcom. They got private cloud at VMware. They're going all in on this direction that you're doing. NetApp makes storage. If you got VAST, DDN, there's network fabrics. Who's your ideal partner to partner with, and why?
Yeah. So, there's a couple answers there. In terms of partners, definitely storage OEMs. The NVIDIA's got their AI data platform play that with the announcement next month, we're going to start doing some, start trying to do some work around that. So some of the ones you mentioned, the storage OEMs are definitely would be great partners. And then in terms of end users for this type of application, it's really enterprises in regulated sectors are, prime candidates. You think banks, insurance, healthcare, health insurance, information exchanges, as well as, typical Fortune 500 type companies that have a big security play. Retail is not a regulated industry in the traditional sense, but, Walmart has a huge security team. So
yeah,
we'll take all those conversations and we're working towards that. And we're also raising a plan to raise our Series A in Q1. So, John, we'll have a little friends and family before.
Yeah. I'll write a check. We'll get some seed money in there. Actually, Series A, we missed the seed round. Nico, great to see you. Congratulations. I love what you're working on. I think, everyone's been launching their vector databases. It's been kind of I can see how people can throw it into everyone's Johnny come lately, but it is going to be a key part. Vector embedding is the language of AI.
You don't need a vector database and you need to secure your embeddings. You need Cyborg DB with whatever database you're using.
All right. Last word there. I'm John Furrier doing our part. We're embedding all the content on the internet with theCUBE, doing our part. Thanks for watching.